Right, so today we are continuing from our calculation worksheet on stoichiometry, and we are now going on to page 10 of the worksheet 7.3. Now, volumetric analysis. So what is volumetric analysis? It's a kind of calculation used to determine the concentration of a solution. You want to find concentration, basically. In the experiment, then the method of the experiment is called titration, but we don't have to worry about titration. That's more for pure chem. So, what is titration? To find the concentration of, so we are trying to find concentration, okay? Now, you are reacting two solutions. One of them has an unknown concentration. That's the one we want to find, our unknown. And to find the unknown concentration, we have to titrate it with another solution with a known concentration. So if it is a known concentration, we call it the standard solution. All right, standard solution. So what we need to know is how much volume of solution X will be required in order to completely, hang on, where did it go? How much volume of solution X is required to completely react with a known volume of solution Y. That is this thing called volumetric analysis. Okay, now that's the theoretical part. You don't have to worry about that. Now, which formula are we going to need to use? So let's recall, we have the formula concentration, we shall call it C. All right, we shall call it C. Then you have mole, which we already know is divided by volume, and volume we shall call it V. All right, so that it's easier for us to write. We don't have to write so much. So C is equals to mole over V. Okay, that's the formula we're going to use for concentration. If we rearrange the formula and we want mole, then what is mole? Then mole will be equals to concentration times volume. Okay, so it will be mole equals to concentration times volume. Or actually, let's be consistent. We use C times V, where concentration is C and volume is V. Okay, so we will be using these two equations a lot. Let's look at the example. So what do we have? We are told in a titration. So whenever you see the word titration, it's telling you that they are doing volumetric analysis. 25.0 cm cube of 0.5 mole per dm cube hydrochloric acid. Straight away, we have these two numbers. We have to annotate it. So 25.0 cm cube is a unit for volume, correct? So let's call it volume of HCl. All right, we put a subscript HCl. So that's volume of HCl. How about mole per dm cube? Mole per dm cube, what quantity is it? Is it mass? Is it concentration? So this is a concentration, so we will call it C for HCl. Okay? Then we have 27.0 cm cube of aqueous sodium hydroxide. Cm cube again, so this is volume again, but for NaOH, sodium hydroxide. So many numbers, you must really go and label it, otherwise you will be confused which number to use. Okay? Next thing, cm cube we never use for calculation. We have to convert the cm cube to dm cube. Okay? So in dm cubed, how much is 25? This will be equals to divide by 1000, 0.025 dm cubed. And here, same thing, 0.027 dm cubed. Okay? Right. Part A. So we are done with tagging all the numbers that we have. Now, what is our unknown? What do we want to calculate? This is our unknown. Alright? Moles of hydrochloric acid. So what formula do we use? What do we have? To know which formula to use, we must see what information we are given in the question. So we are given volume and we are given concentration. So that's how we use moles of HCl will be equals to concentration times volume. So we substitute it in, right? It's concentration times volume, moles of HCl. Substitute it in, concentration is 0.5, volume is 0.025, and you will get your answer 0.0125. Okay, so we are done with the first part. B. Now our unknown is what? Now our unknown is find the concentration. So in mole per dm cube, so now find concentration, but the unit is mole per dm cube and also gram per dm cube. So for sodium hydroxide now, what information do we have about sodium hydroxide in our question? In our question, we only have volume. Alright, we only have that. That's all. And we need to find concentration. So we need moles. Alright, we need moles. So to find mole of NaOH, we need to use mole ratio to connect the NaOH with the HCl. What is the relationship? What's the ratio between NaOH and HCl? So from the equation, we will know that it's 1:1. Right? The equation is here. Okay. So to find mole ratio, go from the equation 1:1, and we substitute the 0.0125 from part A. All right, substitute 0.0125 from part A. Okay, then of course it's 1:1. That means that the mole of NaOH will also be the same, which is 0.0125. Okay, but that's not our unknown. What's our unknown? Our unknown is concentration. So after we know the mole, now we can calculate the concentration. What's our formula for concentration? Formula for concentration is mole divided by volume. Okay? Mole divided by volume. So substitute in 0.0125 divided by 0.027. That is the volume of NaOH. And we will get the answer to be this. Okay, so settled. Done. Oh, not settled yet. That's only part 1. Now we also have B part 2, where we have to find the concentration gram per dm cube. So now we have to convert this 0.463 mole per dm cube into gram per dm cube. So mole to gram. This one no need already. Alright, we already found the answer from the earlier part. So how do we convert from mole per dm cube to gram per dm cube? Let's write down. Convert 0.463 mole per dm cube to gram per dm cube. We have to use the formula mole equals to mass over mR. Okay, this is the formula we have to use. So, mole is equals to mass. Oh wait, we want mass, sorry, all right, we want gram per dm cube. We want gram per dm cube, so we want mass. So we have to rearrange this formula. That means that mass will be equals to mole times mr. Okay, mass is equals to mole times mr. So the mole is 0.463, okay, times the mr for NaOH will be equals to 23 plus 16 plus 1. That will be 3940. So it will be 0.463 times 40. And that should give us an answer of 18.5 grams. Correct? So therefore, it means that this is mass. Then you have to write in the last part. Therefore, concentration in gram per dm cube will be equals to 18.5 gram per dm cube. Okay? Right, now let's do exercise. In a titration, again, we have so many numbers, this. Let's tag all the numbers, okay? 25.0 cm cube is a volume. Volume of what? What substance? So this is volume of NaOH. Okay, 25 cm cube. How about mole per dm cube? What quantity is it? Is it volume? Is it mass? Is it concentration? What is it? So this is concentration of NaOH. Then we have another number, 26.40 cm cube. Cm cube again, so it's a volume, so V. This time, what substance is it? Sulfuric acid, so it's H2SO4. Alright, we tag all our numbers. Now, the first part, calculate moles of sodium hydroxide. So, that's our question. Now, which equation to use? So it's like as though you are going into a battle. You have all your mole equations, that's your weapon. Which weapon to use? It depends on the question. Alright, what do you find in the battle? So in the battle, we have volume, we have concentration. So that's the one. The formula that contains volume and concentration. So that will be equals to mole equals to concentration times volume. That is our formula. And what is the concentration? 0.8 times volume is 25 cm cube, but you have to convert to dm cube. Okay, why like this? Because 25.0 cm cube is equals to 25.0 divided by 1000, which will be equals to 0.025 dm cube. So in case you have forgotten how to convert, it will be like that. And how much is this? This will straight away be... Oh, wait a minute. Am I looking at the wrong thing? Hang on. 0.8 times 0.025. So we will get 0.02 mole. And that's the first part done. Okay, now second part. Find the concentration of sulfuric acid. So our unknown now is concentration. So what do we have about sulfuric acid? We only have this. We only have the volume of sulfuric acid here. Correct? Nothing else already. And we want the concentration in mole per dm cube. So we need mole. So we have to find mole. Okay, we have to find mole. here. Find mole of H2SO4. Okay, how to find mole of H2SO4? Use mole ratio, because the first part we know the mole of sodium hydroxide. So how do we find the mole ratio? First of all, you notice now we don't have the equation. So sadly, we have to write out the equation first. Okay, so equation will be NaOH plus H2SO4 giving you Na2SO4 plus H2O. Now to balance. 1 Na on the left, but 2 Na on the right. Okay, 1 Na on the left, but there are 2 Na on the right. So on the left, we have to put a 2 in front. Okay, now we put a 2 in front. Let's look at the rest. Straight away, we can see that hydrogen will be a problem. How many hydrogens do we have on the left? So for hydrogen, you have 2 hydrogen and another 2 hydrogen. So that's 4 hydrogen, correct? But on the right, we only have 2 hydrogen. So what do we need to put in front of the H2O? Yes, we need to put the number 2. Okay, let's erase off this. Correct? So now let's calculate again. 2Na, 2Na, done. Oxygen, 2 oxygen on the left and plus 4 oxygen, that's 6. So oxygen is correct. Yep, hydrogen is 4 on the left and 4 on the right, so correct. Now it's balanced. Now, mole ratio. So what is the mole ratio? Between what and what? What are the two things that we are talking about? The two things we are talking about is sodium hydroxide and sulfuric acid. So 2NaOH is 2H2SO4. These are the two things we are talking about. 2 is to 1. Okay. Then from the first part, how many moles of sodium hydroxide is there? 0.02. How much is the H2O? Right, from part A. That means that mole of H2SO4 is actually equals to 0.01. Okay, so we have found the mole of H2SO4, but that's not the answer. The answer is concentration, correct? So what is the formula for concentration? Concentration of H2SO4 is equals to mole over volume of solution. So mole we already know is 0.01. What is the volume of solution? Let's go back up to the question. What's the volume of solution? 26.4 here. 26.4. So divide by 0.0264. And that should give us an answer of 0.0379 mole per dm³. Okay, so we have found concentration. Then lastly, find the concentration in grams per dm³. Now find the concentration, so we have to convert the 0.0379 mole per dm³ to gram per dm³. And we do that by using the formula mole equals to mass over mR. Or mass will be equals to mole times mR. Okay, so this will be equals to 0.0379 times, what's the MR of sulfuric acid? Right, so it'll be 2 plus 32 plus 64. Is equals to 0.0379 times 98. And that will give us 3.71 grams. So that's only grams, but now we have to write it out as a concentration. Okay, so write it out as a concentration. Concentration will be equals to 3.71 gram per dm cube. And that's all. Okay? Right. Okay, example 2. Okay, I will still do example 2 for you, but you are going to do example 3 on your own. So this is example 2. So we are doing it again. A household ammonia solution was analyzed to determine its ammonia content. First number, 25 cm cube of ammonia solution. Okay, so straight away, let's annotate it. This will be volume of ammonia. Okay, this will be volume of H2SO4, sulfuric acid. This will be concentration of sulfuric acid. What is our unknown? Calculate the concentration of ammonia in gram per dm cube. Right? Concentration of ammonia. So that's our unknown. Now, and that's all we are told. So whenever you see a big giant size blank, you have to use MRU. Alright? Use MRU method. So first step, find mole of, not ammonia yet. Ammonia is our unknown. So unknown, you leave it to the last step. So find the one that we have the volume and the concentration. So mole of H2SO4. So it will be mole equals to C times V. 0.11 times 0.0219. Answer 0.00241. That's mole of H2SO4. Okay, M done. Now R. R is find ratio. Find ratio, and that is from the equation. So mole ratio will be equals to, whoa, what happened? So mole ratio will be equals to 2 NH3 is to H2SO4. 2 is to 1. So from step 1, H2SO4 is 0.0241 mole. How much will be ammonia? So mole of ammonia, you need to times 2, correct? This 2 is to 1. So it will be 0.00482 mole. So first step done, second step done. Third step, what is our unknown? So our unknown is we have to find concentration, but not in mole, in grams. Alright, in grams. So convert 0.00482 mole to grams, because that's what our unknown says. How to convert to grams? What's the equation? What's the weapon we need to pull out that will convert mole to grams? The mass formula. So mole equals to mass over MR. Okay? This will be of ammonia. So this will be equals to, mass is our, we want grams. So mass will be our unknown. Mass will be equals to mole times MR. So mole is 0.00482 times 14 plus 3. This will be 0.0819 grams. Still not unknown yet, because our unknown is actually concentration. We have to convert the mass to concentration. So concentration will be equals to mass over volume of solution. Mass is 0.0819. What's our volume of solution? Let's go up. This is for ammonia. So ammonia, what do we have? For ammonia, we have the volume is 25. Okay, so that's our volume. So it'll be 0.025 dm³. 3.28 grams per dm³. Is that okay? So it's using our MRU method still, but with an extra step, because calculating concentration, you need two parts to it. Now, 3, try on your own. Do yourself. Pause the video, and try this out yourself. Pause the video now. I give you a hint. Alright, hint, use MRU. In fact, actually the earlier part also is MRU, just that they split the MRU into A and B. Alright, but basically it's MRU. You always find mole first. And in fact, that's a very good escape card. Right? You don't know what to do, you're in a situation and you don't know what else to try, what else to do, find more. Right? It will help. Find more. That's your hint. Okay, do yourself. Pause the video. Okay, model answer now. Model answer. Find mole of KOH. Okay, so this is concentration of H2SO4. This is volume of KOH. This is concentration of KOH. Okay, so first step, you have volume of KOH and concentration of KOH, find the mole. Oh, what happened? Find mole of KOH. So it'll be mole equals to concentration times volume, 0.4 times 0.025, 0.01. Okay, so why 0.025? 25 cm cubed is equals to 25 over 1000 dm cubed. Okay. So, first one done. First step, find mole. Part 2, find ratio. So, mole ratio is equals to 2 KOH is to H2SO4. Is equals to 2 is to 1, which is equals to 0.01 is to what then? So, obviously, mole of H2SO4 will be equals to 0.01 divided by 2. 0.005. Oh. So part 2 done. Then part 3, find unknown. And our unknown is volume. You want to find volume of sulfuric acid. Okay, so we know mole of sulfuric acid. So we know mole. What is the formula that connects mole and volume. It will be concentration times volume. So mole is 0.005. Concentration, is it our unknown? No, we know the concentration, 0.1. Concentration is 0.1 times V. How much is V? The 0.1 must bring over, it will be 0.005 divided by 0.1. This will give us 0.05 dm cubed. So write it out nicely. Volume of H2SO4 equals to 0.05 dm cubed. Is that okay? Right, next part. Okay, I'm going to stop this video for now, otherwise the video will get too long, so there will be a part 2. Okay, we stop here for now.